Okay, so we're on page 4 in your packet. Number 7, remembering how to use all of our trig functions along with Pythagorean theorem in order to be able to do what is called solve the triangle. Solve the triangle means find all the missing measurements, all the angles, all the sides, and typically they give us 3 of those, and I'm going to find the other 3. That's usually the generic way. But solving the triangle, just so you know, that means find all the measurements, every angle, every side. First, we'll start by labeling our triangle. This one, they've told us, is called triangle BXA. So X is my right angle, and then I'm going to go ahead and label B and A. So then that would indicate the sides opposite each angle. We use the lowercase letter to describe the sides corresponding with the angle that's across from it. The first thing I would find would be the third angle. I'm given 2 angles right now. It's fairly simple to find the third angle because we know the angles inside of a triangle add up to be 180 degrees. So you don't have to start with that. That's just what I'm choosing to do. And we'll go from there. So I'm going to find the measure of angle A. That little M means measure. So the measure of angle A. And I'm going to do that by subtracting 90 and 51 from 180. So 180 minus 90 is 90, right? And then minus 51 gives me 39 degrees. Good. So I'm going to, let's see, 39 degrees. Make sure, without a doubt, you put the degree symbol. If you don't, then it's saying 39 radians, and that's not what we need. Okay, now, from there, I can use my trig functions in order to find the sides. I only know one side. 2 sides are missing, so Pythagorean theorem's not an option for me. I've got to use trig functions, sine, cosine, or tangent. And then I have to decide, well, which one am I going to use? Which we don't have to all choose the same one. Yes, sir.
You can find the adjacent and then use the Pythagorean theorem to find the hypotenuse, right?
Sure, you could find one of the sides, either the hypotenuse or the adjacent. You could find any side and then use Pythagorean theorem. Absolutely, that is an option. So first of all, I know I've got to use trig at some point. Before I decide sine, cosine, tangent, what do I have to decide? Nice. Theta. I have to know where to put theta. It can never be the right angle, but it can be either of the other 2. And you might pick a different one than I do, and that's okay. I'm going to choose angle B down here. I'm going to choose this as my theta, mainly just because they gave it to me. That's the one they wrote in the problem, and I kind of tend to lean that direction. That's just me and my personal preference. It has nothing to do with right or wrong. I'm going to pick this as my theta, so that means this is the opposite side for me. And adjacent, I already know hypotenuse. Labeling, even with just a letter, is super helpful. I'm also going to just jot down SOHCAHTOA because it gives my brain a little bit of a break just to be able to look up and see that. So now I get to choose which one I want, sine or cosine or tangent. And there'll always be at least one that you're not able to use. Like, for instance, I would not be able to use cosine. For this one, I would not be able to use cosine of theta because, why? Do we know why? Right. We don't know either of those. We don't know adjacent. We don't know hypotenuse. So that would leave 2 unknowns in my equation. Not good. So we can't use cosine, but I could use either of the other 2. Let's do, I mean, it doesn't really matter. Let's use sine. Let's use sine of theta which is opposite over hypotenuse. And I just picked it because no reason. Sine's kind of my favorite. I don't know. So in this case, I know what theta is. My theta is 51 degrees. The opposite side, I know it is 14. And the hypotenuse is what I'm going to be finding. How do I solve an equation like this with the unknown in the denominator? We multiply both sides by the denominator. That's how you'll always get rid of a fraction, is to multiply both sides by your denominator. So now I'm going to have to, divide by sine of 51 degrees in order to get x by itself. And go to my calculator, and we're going to type in, first of all, make sure on your calculator that you are in degrees mode. Remember the word right there, like this one happens to be in radians, so I need to go over and change it. And then we're going to do 14 divided by sine of 51. 18.015 because I need to round to the third decimal place. All right. There's my hypotenuse length. There's this. Now, I'll go ahead and tell you, like, we're at a higher level of math, right? And so you may recognize the little equation. We're going to have that same kind of equation over and over while we're doing trig. So if you recognize that your unknown variable is in the denominator of your fraction, you don't have to write all of those steps if you recognize that it's going to be the numerator divided by the trig function. If you do, then you can just kind of jump to that step. Like, for instance, I'm going to go ahead and do another trig function just because it's new to us and I want to use those as much as possible. So this time I'm going to use tangent. Tangent is opposite over adjacent, TOA. So tan of 51 degrees is 14 over A. So like here's an example. I have a variable in the denominator. So I know all of the steps are going to lead me to this place where I'm dividing my numerator by my trig function. So I'm just kind of not writing all of those steps. I'm not usually an advocate for not writing steps down, but if you're actually doing your practices, like you should be, if you're working all of these problems that are in the packet, then it gets a little repetitious and it's not really, you don't have to write it 45 times. Okay, let's go over here. 14 divided by tan. What do we get? Round to the third decimal place. So 11.337. And that is solving a triangle. Solving a triangle. Find all the pieces of information that are missing. 3 angle measures, 3 side measures. Questions? Okay. There's several more examples of these, and so it really is an advantage for you to do as many of those as you can because they're all slightly different. Same general process, but they're all, each triangle is unique. All right. So today, now in this case, let me go back here. We solved the triangle, so we had to find all of the pieces that were missing, all the parts that were missing. Today, our lesson is on application problems. And so an application problem is a word problem. I'm not always going to have to find every missing piece of information. Most likely in the word problem, you're just going to be finding one. So you don't have to find everything. You just need enough information to find whatever the problem's asking you for. So in order to do the word problems, we need to discuss one thing first, and that would be angles of depression and angles of elevation. Again, this is an example of how we're pulling in geometry and combining it with algebra, which ultimately gives us the pot called trigonometry. And so we just need to remember a few things. Angles of elevation and depression are basically forming right triangles based upon the line of sight. And so if I were standing outside in front of school and I were looking up at the top of the flagpole, like let's say that were the example that I'll use here. If I were standing outside looking up at the flagpole, the angle of elevation is from my line of sight, because we're looking for something that's going to form a right triangle. So we're looking for a parallel situation and a perpendicular situation that's going to give me what I want. This angle here is called my angle of elevation. And then conversely, if I were standing on top of the desk and I were looking down at the bottom of the trash can. So I'm standing on top of the desk and I'm looking down at the bottom of the trash can. Then the angle of elevation exists from my line of sight, which would give me a line parallel to the ground, down to the bottom part of the trash can. So, like in this instance, this would be my angle of depression. So depending on the scenario that they're trying to build in our word problems, this may or may not be given to us. Now, do you see the right triangle that is formed here with this angle of elevation, where we said, we're looking for the line of sight, which indicates, the parallel to the ground, looking up at the flagpole or whatever it may be in order to form the right triangle. And I also am noticing that the angle of depression is not inside my right triangle. It's not even inside. So at first, it seems like that's not going to be helpful at all. They're giving me a piece of information that's not even inside the triangle that I'm forming so that I can figure out these missing measurements. But because of the fact that there's a relationship between the angle of elevation and depression, they are actually congruent to one another. So if they give me the angle of depression, the reason that's good for me is because I know it's congruent to the angle of elevation. So I can use that same measurement and write it down here for this angle, and then go about my business to try to figure out my missing measurements in my right triangle. Does that make any sense to us at all? So just for just to ask, because it's not that big of a deal, but do you remember what geometric theorem is proven to state that those angles are congruent? I mean, that's a big ask, right? That's digging way back into the geometry days. But ultimately, it's showing us that there's two parallel lines here. The lines of sight are our parallel lines, two parallel lines that are cut by a transversal give us alternate interior angles congruent. Am I ringing any bells at all? That was, if you had to do any proofs at all in geometry, hopefully you recall that. And again, it's, if you needed to know that, you could easily, it's Googleable, right? But I always like to see if it causes you to remember. But that's basically what that is. Angle of depression and elevation are alternate interior angles. And so because of that relationship, we know that they are congruent, and that's how I'm able to use them in these word problems. Okay. These word problems are all about the right triangle. So ultimately, that's what you're going to be looking for. You're going to read the description. You're going to draw a picture of the, it says draw a picture of the problem. That's because I like to draw like a little scenario, but all you need to draw is your right triangle diagram. You want to label the right triangle with the measurements that are given. And then we're going to use our trig functions or possibly Pythagorean theorem in order to be able to find whatever's missing. Our default's always going to be to round to the thousandths place. Always, always, always. Unless the only time we wouldn't do that would be if the problem states for us to do something differently. Like if it tells you to round to the nearest foot or something like that. Otherwise, it's always 3 decimal places for us. Okay, so let's dig into our first example. We have to read the problem, try to figure out what they're telling us, and then draw our right triangle. We have a telephone pole that's 60 feet tall and a guy wire, which I'm guessing we probably don't know what a guy wire is, which, I mean, we don't even really have telephone poles that much anymore, but if there was an independent telephone pole standing on its own, actually, probably a better way for you to understand it would be like if, you know, when you plant a new tree, or if you've seen in your neighborhood, if a new tree gets planted and it's spindly and white, you know, weak, they attach those wires to them and like stake them into the ground so that the tree doesn't, you know, like fall over in the wind and die immediately. That's kind of similar to a guy wire. It's the wire that connects the tree and then gets staked in the ground to give it support to hold it up. And there's, you know, usually one on either side, right? So here's my little telephone pole. Here is the ground, which is going to be forming our right triangle here. Okay. So I've got a 60-foot telephone pole. Let's see. The wire, it says, is 75 feet long from the top of the pole to the ground. And they want us to find the angle between the wire and the pole. Find the angle between the wire and the pole. That's up here. So that's going to be my theta. Okay. That's the hardest part of the word problems, honestly, because we've done the trig. We know how to solve a triangle. The hardest part on these applications is just understanding the scenario and actually drawing the right triangle to get the measurements where they belong, okay? Because every once in a while, they'll throw in things like a guy wire. If you don't know what that is, you know, then we might be in trouble. Once I label my theta, I'm going to go ahead and label my sides. And then figure out what trig function I'm going to use. In this case, I'm looking for the angle measure. And I'm given adjacent and hypotenuse. So what trig function is going to use adjacent and hypotenuse? Good, cosine. So that's what I'm going to want to use. Cosine of theta is adjacent over hypotenuse. So let's fill in the measurements we know. And it's a little different. We're looking for the angle measure, right? Remember how we are going to put that in the calculator? Nice. Yeah, go ahead.
I got 36.7.
Good. That's absolutely right. Very nice. So this is when we go to our calculator and we're going to type in the inverse of cosine. So the blue button and then cosine and then put in the fraction 60 over 75. That's it. Yes, ma'am. Just like this. So it was, we're used to rounding to the third decimal place. So I love how you did that already. Now, on a word problem, always, before you put the box around the answer and you're done, go back to your problem and double check. You want to make sure, and sure enough, this one says to the nearest degree. To the nearest degree. So that means to the nearest whole number. So my final answer here should be what? 37 degrees. Very good. Yeah. Yeah, and that's part of the problem actually, and we're at such a high level of math now that we have to be mindful of all the details and things like that. It's a major detail. So you got to have the degree symbol or you lose points. You got to have it rounded correctly or all of the points would not be available to you. Well, they're available, just not earned. Yay. All right. You take a look at the next one and see if you can draw the right triangle without my help. See if you can read the problem and get the triangle set up without any help.
So the distance of the pose phone is not the hypotenuse; it would be adjacent, right? Because this would have elevation, distance, and account as well. This would just be like how much it actually traveled, right?
Good question. Let me ask everybody because they're all going to have the same question. Okay, hang on just a second. I'll tell you. All right, let's talk about this because this is always a question. Usually, it's which am I looking for, the hypotenuse or that side down at the bottom? The problem reads a plane rises from takeoff and flies at an angle of 10 degrees with the horizontal runway. Most of us can easily imagine where that 10 degrees belongs. When it gained 500 feet in altitude. So, first of all, tell me what altitude means. The word altitude. The height.
Yeah, elevation.
Yeah, the elevation, the height of the plane. So the altitude is going to be this measure over here. So 500 feet. So once the plane has reached an altitude of 500 feet, find the distance that the plane has flown. No. I was shaking my head because that's exactly what Arjun was asking. It's a big question, right? Which one is it? It's let me read it again. It says, what is the distance that the plane has flown? Yeah, if it said the plane is taxiing across the runway, like taxiing would mean they were driving, right? The plane's on the wheels, like bloop, 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 trying to get there. So if the distance that the plane fly means in the air. So the flight, it's done, the wheels are up. The wheels are not touching the ground when it's flying. So the distance the plane has flown is the hypotenuse. The distance that the plane, drives on the runway. If you're going to drive there, then it would be the other one. Does that make sense? So see, that's a big deal. We have to kind of learn those things because we don't always just know automatically. Alrighty, so I'm going to definitely use this as my theta, the 10 degrees. My hypotenuse is what I'm looking for. So, what trig function do we like? Good. I would say yes, I would agree. This is my opposite side that I know, the altitude I know. So I would think that sine would be the best choice. So sine of 10 degrees is going to be 500 over the hypotenuse. So I go to my calculator, I find the value I'm looking for, and before I put a box around my answer, before I say that I'm done, I go back and double check what it's asking me to find. Always do that with word problems, and then you're always going to need to check to see if you have to include units of any sort. This one says to the nearest foot. So how am I supposed to round here? To the nearest foot would mean to what decimal place? A whole number, right? Yeah. No decimals. No decimals, just a whole number. So this one's going to be 2,879 feet. Just like you have to have the degree symbol, you've got to have the units. You got to have feet, or we have to lose a point here or there. So now that we're getting better with the trig, the hardest part is just reading the problem and knowing which side to label. Alrighty, so let's see. Why don't we do one more together? Let's do the ladder. The ladder problem over here, number 4. Because this one talks about an angle of elevation. So let's do one like that. Number 4 on the next page. So on this one, we have to decide where's the angle of elevation. And well, let's think for a second. Think about the ladder, and the ladder, our line of sight is our base for the beginning. And if the ladder has to be then leaned up against the house, so it's got to be elevated in order to lean up against the house. The one at the bottom right. Mm-hmm. It would be the angle of depression would be outside of angle of depression's never inside the triangle, so angle of depression would be out here.
So anytime it says elevation, it would always be on the bottom. Or is that your case?
That's a good way to think. I've never really narrowed it down like that, but yes, it's always inside the triangle. And let's see, right here. Correct. Yes. So this is my 74 degrees down here. So what trig function do we want? Again, let's do, yep. I think that would be the best because this is my theta. Opposite's the one I want to find. Hypotenuse I know. Sine of 74 degrees is opposite side over 16. And what did we get from our calculator? Good. So double check before we put our box around it. Does it tell me any different way to round? Nope, that's it. So we do definitely want to include our units. So 15.380, what are we measuring in? Nice, thank you. Feet. There we go. Not so bad. It's just the and sometimes it's with experience, with real world problems. sometimes you need real world experience. You might not always know what a scenario like unless you work outside, if you're, on the ladder, or, unless you know something about telephone poles. That's kind of all what we're doing here is we have to learn those things as well. That whole future ready stuff, right? Part of it. Alrighty. So for today, I'm going to ask that you would complete, I think it's over, yes, page 9. Page 9. I just picked out a few, like 6 through 8, I believe. They're all good problems. They're all going to prepare you for the assessment that's next week, next Friday. But for now, if you'll begin working on page 9, problems 6, 7, and 8, then that'll give you some practice time and you can ask questions while we're here.
Hold on.
Yeah.